that accuracy is rather high. And if we do not use the specifications, this part accuracy will obtain earlier. So using this method, we can improve the accuracy of the solution, and we can change the properties. Actually, we can change it in two ways, but I think this one is quite straightforward. We can use this one to set the properties. So let's go back to the original one-variable function. For the one-variable function, you may still recall it. I can draw the curves of it. And the accuracy using graphical method is something like 10 to the power of minus 5, which is quite low. And now let's consider solve this equation by analyzing the function solve and see what happens. If we use solve command, this is the result we finally obtain. So t equals to and if we substitute this result back to the original equation, we will see that the error is around 0. It's very accurate. So it seems that the solve function also can be used to solve this kind of problem. However, in the solve function, we are not allowed to select the initial searching point. So for this equation, we can only find one solution. Well, with the use of numerical method, we can find other solutions apart from that one. So we can find another solution. And the curve I saw earlier is something like this. In the area we may have 3 solutions. But using solve, we can only find this one. We cannot find others. And use the numerical function f, so we can find whatever function you need. Besides, this result is obtained by graphical method, and we can use that one. Since this solution is not accurate, so we have to use that one, and then combined with the numerical method, we can find a more accurate one. So we can improve the accuracy of graphical method in this way. We can use graphical method to locate the interested roots, poles of the equation, solution to the equation, and then we can use it as a starting point and search for more accurate ones. So the idea is quite straightforward. Now we have to make a summary on the 3 types of solutions to nonlinear equations. We have mainly described 3 ways. One is by graphical method, the other one is by quasi-analytical method, and the other one is by numerical method. The advantages of graphical method is that we can show graphically or in a visualized way that all the possible real solutions within the areas of interest. We can display all the solutions. And the disadvantage is that it is only applicable to one-dimensional or two-dimensional equations, and also it is not accurate. And apart from these, they can only find the real solutions. So these are the graphical methods. And sometimes we can use the benefit from it. For instance, we can find all the possible real solutions to one-dimensional or two-dimensional equations. The other one is quasi analytical method, we can use the solve command. And the advantages are that we can find the real and imaginary solutions. And normally the method of the solution obtained by solve function is that they are more accurate than other methods. However, the disadvantages is that it will only be used for polynomial type of equations. And also for non-polynomial type of equations, the method does not allow you to select the initial search point. So these are the limitations of the method. So let's move on to the pure numerical method. It can be used to solve equations of multi-dimensional, not only one-dimensional, two-dimensional. It can solve numerically multi-dimensional function equations. It allows you to select initial points. It allows you to select initial points. Then you can actually, normally you can use the graphical points, graphical method points, and use it as the initial point to increase the accuracy of the solutions. And the disadvantages are that they are not possible to find the imaginary solutions, and they can't. And we can combine some algorithms together, as I said, to use graphical points to find the interested root, and then use it as an initial search point to find more accurate solutions. So now I have